Alright folks, hello and welcome to this video example on section 1.6, classifying polygons. Please copy down these definitions and examples into your notes so you have them for reference and for future study. So finally we get to shapes in geometry, and we're going to use the official term a polygon. A polygon is a closed plane figure such that two things are true. It is first formed by three or more line segments, and those are called the sides. And two, each side intersects exactly two other sides in the figure, one at each endpoint. Okay, and we're going to draw some picture of these in a moment so you get a look at what they are. Some other terms you need to know. Each endpoint of a side is called a vertex. Oops, sorry about that. So the vertex is the endpoint of a side, or a point where two sides come together in a polygon. And we name polygons by listing the vertices in consecutive order. So here's example one. We're going to look at some figures, and are they polygons, are they not polygons? That's what I want to determine. Here's a figure. There's another figure. And there's one more figure. So for each of these, I'm just going to ask you to assume that they are straight lines that I drew. I know they're not perfectly straight, and also assume that the stopping points are actual points. So there's no curves here, they're just straight segments, and we're going to see, are these polygons or are they not? With the first figure, it kind of looks squarish, almost like a kite, and it's formed by four straight segments. So that's the first part of the definition. It's three or more line segments, so that's good. And then each side intersects two other sides in the figure, one at each endpoint. Well, let's see if that's true. So each side, let's see, this side here, right there, that intersects two other sides, right? There's one there coming off of it, and there's another one there coming off of it. So if I look at the blue side again, to emphasize, there's our one side. Where does it touch two sides? Well, it touches one here, and it touches the other one there. That's where they intersect, and so that fits the definition. And you can go around the square and show that that works for all the other sides as well, or the squarish figure. So this would be a polygon, and we would write yes. For the next one, we want to determine if it's a closed plane figure that fits the definition, and it does not fit this part of being a closed plane figure. So this is not a polygon because it doesn't enclose a specific region. Because these endpoints here are left open, it's not closed, right? They're left open. And secondly, these sides don't intersect the other sides at each endpoint. So if I were to call this a side here, this segment here, I'm kind of highlighting, well, at this endpoint, it doesn't intersect anything. It doesn't intersect anything, so that violates the definition in two places. One, it's not closed. Two, it doesn't intersect the sides at the endpoints. Let's look at the third one. This is also going to be no, not a polygon. And that's because even though there are straight segments that are the sides, there's at least three of them, and they each intersect other sides at an endpoint, so there's nothing wrong with that. It's a closed plane figure. However, look at this endpoint here, for example, this one here, and notice that there are three sides that come off of it. Or if you were to look at this segment here in the center that I'm highlighting now, notice how it intersects with two sides at this endpoint. That's not allowed because of this part of the definition. It can only intersect one side at each endpoint. So we could say this whole figure is not a polygon. Is there a polygon inside the figure? And that is actually going to be true. If you were to kind of like separate this and make it into two triangles, you can consider those polygons. So in this figure, you can still consider part of the figure a polygon. You could say this triangle is a polygon, but the whole figure itself is not a polygon. Next up, we have a couple more definitions. All polygons are either convex or concave. They are convex if a polygon is convex if none of its sides extended enter its interior. A polygon is concave if it is not convex, or if it quote-unquote caves in. So let's look at three more examples here. Polygons that are either concave or convex. And here we go. In this first one, we can check if it fits the definition for convex. If I extend its sides, do they enter the interior? Well, let's extend them. Here I'm extending the side, I'm extending the side. You can do this in your mind or on paper. I'm extending the side, I'm extending the side. And no matter how I extend them, it never enters the interior, which is this area between the sides, the closed figure, or the closed part of the figure. So since it never enters the interior, we can declare this convex. Next up, we have this figure here. And notice how it has a curvy portion. So is this convex or concave? Well, it kind of caves in here, but really what we want to say is this is not even a polygon at all. Okay, this is not a polygon because a polygon can only have... Recall the definition of a polygon, where it says you can only have straight line segments at sides. This is not a straight line segment, so it's not a polygon. So we won't consider that one. The last one is going to be concave. Yes, because it caves in this portion here, and yeah, these are connected for our sake. They're supposed to be connected. This is a cave-in, so to speak, and but more important, if I extended it, see how the side cuts right through the interior of the shape. It does hit this interior portion all in here. And if any side extended hits the interior, it's concave. So that rounds up just a summary of our 1.6 intro. First, we defined polygons. We determined if something was a polygon or not. We talked about the definition and the various conditions. And then lastly, we determined concavity, which is a fancy word for saying whether something is concave or convex. Make sure you have these definitions and examples copied into your notebook. Thanks for watching this video lesson.